So let's go back to small intestine. So our food left the stomach and got into the small intestine. It's called small, but it's actually the longest part of the digestive tract. It's about 6 meters or about 20 feet in length, but it's pretty thin. That's probably why it's got this name. Its diameter is about like 1 to 1.5 inches or 2.5 centimeters to 4 centimeters. And the small intestine is the place where digestion happens. So that's where the macromolecules from food are broken into smaller particles and using the enzymes produced by the pancreas. This is the example of chemical digestion. And then the products, these small nutrients that can be now used by the body as a fuel or as building blocks, are absorbed into the bloodstream. So 90% of absorption happens in the small intestine. There are 3 regions of small intestine. The first one is called duodenum. It's pretty short compared to the rest of it. And that's where the food goes right after the stomach. It gets neutralized by the secretion of the pancreas. It gets mixed with the enzymes, with the pancreatic juice, and that's where the lipids are emulsified by the bile acids and digested. So this is the part where most of digestion actually happens. So when you digest food, you don't do it in your mouth, you don't do it in your stomach, you do it in the small intestine, in particular in this part of the small intestine. Then the next part is called jejunum, and that's where most absorption happens. And then it's finished with the ileum. Some absorption continues there, like vitamin B is absorbed, bile acids are returned back to the body, and some other nutrients. And the structure, I want you to take a look at the structure of the small intestine that actually helps it to absorb the nutrients. So the lining of the small intestine has these folds, about 800 of them, about like 5 folds per inch, circular folds, and they are rolled to increase the surface area of the small intestine, because the bigger is the surface, the more efficient will be absorption of the nutrients. And here you see this folds. It's actually interesting. This is not a healthy intestine. These are cancer formation, but that was the only picture that I could find. So circular folds on the inner surface of the small intestine. To make the surface even bigger, each of these folds, like this is the fold, and you see it's covered by this little finger-like protrusions that's called villi. Villus for singular and plural. So villus inside has capillaries that will pick up the nutrients that would be absorbed by the small intestine, and also lymphatic vessel called lacteal. This one will pick up the fats that or the products of fat digestion or lipid digestion. So we already have folds, circular folds, and on top of these folds we have this villi, which increases the area of absorption. But this is not enough. So these cells on the surface of villi, if we look at their top, we'll see even more protrusions. That's called microvilli. Sometimes they're called brush border, because if you look at them under the microscope, electron microscope, you will see they do look like a brush. So these are not cells. These are little protrusions on top of these cells, like these cells, microvilli or brush border. And all of this like complicated structure has evolved to provide one function: efficient absorption, because the higher the surface, the more efficient will be the absorption. And this increases the surface by about 600 times. One topic that's related to small intestine is lactose intolerance. So as I said, digestion of all compounds, including carbohydrates, happens in the small intestine, but not lactose in case of lactose intolerant people. Instead of being broken into two smaller molecules, lactose is transported into the large intestine. And in the large intestine, there are a lot of bacteria who are very happy to digest this lactose. And these bacteria create the gas. They create various abdominal symptoms. This unbroken lactose creates the flow of water in the intestine, and that's what causes diarrhea. So why do we have two types of people, lactose intolerant and lactose tolerant? And for many years, I believed that lactose intolerance is a kind of disease, or maybe mutation that makes people unable to digest lactose. It's actually completely the opposite. So normally, normal situation for the adult organism, for the mammal, and humans are mammals because we feed our babies with milk. Normal situation will be that when some mammal grows up, they will not have milk, because the only access to when the such organism has to milk is when it's suckling the mother. When it grows, there's no mother's milk, and then what's the point to produce enzyme that would break this milk? So this enzyme is the enzyme that breaks lactose. It's called lactase. It's produced in babies, but then when babies grow up, this enzyme is not made anymore because, what's the point? But sometimes, about 10,000 years ago, there was a mutation, and there was one of these rare cases. Usually mutations screw up the body. Usually they are harmful, but in this case, rare case, this mutation was beneficial. And humans, those who have this mutation, continue to produce enzyme that breaks lactose throughout their entire lifetime. And that was very good because at this point there were some nations and tribes that were nomads that were taking their animals with them, the herds of animals that they milk. So they were able not only use these animals for meat, but they also could drink milk. And then this mutation appeared somewhere in Asia, and then it spread out through Asia, through Europe, and then was brought to the Northern America. As you see, actually most of the world is lactose intolerant. So if you're lactose intolerant, you can at least tell yourself that you are not a mutant. You are a completely perfect person. Okay, so that's what I wanted to tell you about small intestine, and the next topic will be large intestine.